Hello everyone, how it's going? So today we have a new video. This time it's about another module that the ones that I showed you before. So basically I already have one video in my channel regarding a tachometer or speedometer that you can use for measure the RPMs on the spindle of your machines. So basically it was a setup video for a really simple tachometer, and I was trying to find something different, something if possible better, because the other one has some cons, like for example the refresh rate is really slow, and also I would say that the resolution is not the best. So I was trying to find something with the more or less same price, but that could offer us a bit more functionalities. So I was able to find this tachometer that I will leave you the link in the description. So on this video what we are going to do basically is go through how to connect it, some key features, talk about regarding all the functions that this tachometer has, and we are going to do a test with a comparison of the other tachometers or speedometers, and also a specific tachometer that we know that it is working as expected. So we are going to be able to have a comparison. So if you like this kind of videos, please give it a like, subscribe. Also you can follow me in my Instagram, because I used to post there more often than in YouTube, because it takes less work to me. And basically, let's start with this tachometer. So basically, this is the model that I was able to find. Okay, I will left you the specifications in the screen as well. But basically, this module can work between 9 and 24 volts. Okay, it can measure from less than 30 RPMs till more than 8,000, and the resolution change, it depends of the speeds. So basically between 30 or less than 30 the display is covering all the lines. If it is between 30 and 1000 we have one decimal, and above 1000 till 9999 we have this decimal, well, we have one revolution, and above that we have 10 revolutions, right, of resolution. So just to let you know that this is the main features. The size is like another module, so they used to be quite standard. And also another important thing of these modules is that it is not only RPM or tachometer, but also counter. So we can use this module as well to counter steps. It means that when this inductive sensor count or the magnet is going through it, so it will count 1, 2, 3, and so on, in a way that we can know how much counts do we have, or working as a tachometer. So basically, this is what it is coming with the tachometer, plus one magnet that right now I don't have it here, but basically the module with some instructions, really basic. The best is to go to AliExpress to see how to connect it. And also here you can see the different things that I explained: the voltage, the RPM range, and the count range. Also two cables. This one is for the alarm, because this is another feature that this module has. So basically what we can do is configure in a way that in count mode, okay, when this is counting steps, if we go above certain number of steps, this alarm will be enabled. So for example, one interesting thing that this could be used is we need to count something, parts that they are metallics or number of turns, and stop. So basically we can program how many counts do we want to have, and this alarm will be triggered when this threshold is achieved. Can be configured higher threshold or lower threshold. And also we have this cable here, that it is the main cable for connecting the encoder, well, for connecting the inductive sensor and the power and the inductive sensor. That one thing that I like, I mean they used to be always the same, but one thing I like from this one is that it is really compact, right? It's not so long like another sensors that we are able to find. And we see here a bit more details regarding to the encoder sensor and the part number. okay, in case you want to take a look. Probably I will leave the part number in the screen. And this is what comes with the module. As you can see, not many things, but what we are going to do now basically is to connect everything. I will show you how to connect everything in a really easy way, and later on we are gonna see how it works and a bit the configuration of the display. Okay, so basically we have here the encoder. Okay, as you can see, it has 3 cables, so brown, blue and black. You can see another video showing how to connect this kind of tachometers in my channel. I will leave you a card here, but anyway, let's go with this one. And we have the main cable, right, with some cables. So it is important to you to know, and I will leave you as well a connection diagram in the screen, that from this connector, red and black, they are the power. So basically black is the negative that needs to go to the negative of the power supply if we want to use 12 volts, for example, and the red needs to go to the positive. Okay, so these two we can put it aside, and if we connect here the cable, okay, let me connect it. So we can see that the black and red, they are the positive and negative. Don't follow this label because it's not okay, right? It's important. I think they placed it the other way around. It needs to be in the other direction. So now we go with the next one, the yellow one, which is the middle pin. The middle pin is going to be to the blue cable of the encoder. Okay, so as you can see here, we put this here, and what we are going to do is basically to solder the yellow with the blue one. Okay, so we already have it. Now the next cable that we have here is the green one. Okay, as you can see, so the green one is going to the brown one in the encoder, as you can see. So we place this here. Perfect. And the latest cable, which is the blue one, it is going to the black one. As you can see, it's a bit counterintuitive, but yeah, if you follow this video or the instructions that I left you here, this will work. So basically we have the encoder already connected. I recommend you to put here some heat shrink or something in order to avoid the cables to have contact, but for the moment, for my purpose, it will work. So let me left the iron there, and now what we are going to do is to connect the power, so that we have here, okay, red and black, and I will show you a bit how this tachometer works. So let's connect this one here, and the positive in the positive, right? Okay, and as you can see, this is already working. So basically, let me take one magnet in a way that you can see how this works. Another important thing that I explained in the video, as you can see now it's working, this will be RPMs. Another important thing that I showed you in the previous encoder configuration is that one of the sides of the magnets, it's not going to work, as you can see. So before fixing the magnet, you need to see which is the sides that make this LED bright more. So as you can see, this does, the other one no, right? So important thing when you configure or when you glue your magnet into the axis that you want to see. So as said, one of the special characteristics of this tachometer is that you can configure how many magnets do you have in the axle. So this means that imagine that you have an axle that it is really big, so you can put 3 magnets in a way that you can configure the tachometer to read the 3 magnets, and it will be more reliable, right? Because we will have less time between the magnets to go through the inductive sensor. So this is one of the interesting features of this controller, and I will show you a bit how to configure it. So basically, with this button that it has 3 points, we can enter into the menu. So we see here one FC, that the function selection basically is for selecting which function do we have. So counter, C is for count mode, S is for speed mode, okay? That in the, I will say in the manual is wrong, they specify F, but as said is S. And for entering, so basically what we do is we press here and we enter, or we accept the configuration. The second one is the number of poles or of magnets that we have, that if we enter, we see that we can put till 3 magnets. So this can be configurable. It depends, as said, how many magnets do we want to place on the axis. So we are going to do some testing later how this works, and also in comparison with another tachometers. So let's go to the next function. So the number 3. The number 3 is the low, let's say, speed alarm, in a way that if the speed is going below this value, okay, what we can do is to trigger the alarm. Let's say that we have a motor working and we want to stop something when the motor stops. So basically we can use this for this purpose. So let's keep it in 0. The mode number 4 basically is like the mode number 3, but for the high end of the count. So basically what this is going, if we have a motor that it is going above 13 speed, let's see, we configure here 3000. So basically if it is going above 3000, this alarm is going to be triggered. And we have the latest mode that basically is the alarm, but for the count mode, right? So if the count is going above 13 number, let's say that we want to count turns and we want to stop something after 100, so we can use the alarm in order to put here 100, and the alarm will be triggered and we can trigger another actions, right? So basically that's all regarding to the controller. So all the configuration that we can have, and I will show you just how the mode we encounter works. So basically now we have it in counter mode, and what this does is, if we put here the magnet, so as you can see, it is counting, right? So this is the purpose of the counting mode. So basically these are all the functions that this module has. And what we are going to do now, we are going to go to my lathe. In this case, we are going to set up this tachometer, because I will say that most of you, the usage that you are going to give to this controller is basically a tachometer. Let me know if you want me to explain a bit more regarding to the counter, but for the moment I will focus on the tachometer. So let's go to the machine and let's compare the different modes that it has with the different magnet configuration, and let's see how it works. Okay, so we have the setup ready. We are going to test different modes and how they behave. So as reference, we have the Uni-T speedometer, okay, that it is the, let's call it the most precise. The second one, we have the standard tachometer or speedometer that you can find on AliExpress that has no option. And as third one, the one that we have been showing before, how to connect it, the functions that it has. And right now, this first test, it's going to be, this tachometer only have one magnet, because it's the only possibility that this offers, and this one has 3 magnets, okay? I will keep it in the screen so you know what we are doing, and we are going to test at low speed, mid speed and high speed. So let's start with low speed. As you can see, this updates much faster, and the precision is quite okay, but it is less stable than the one that we have here, that it has only one magnet. So as you can see, less stable, and the Uni-T that it is showing 39.740, okay? So we stop, and as you can see, this updates faster. So the reaction ratio for this one is, as I said, better. Now we are going to go to mid speed. It's reacting faster like the Uni-T, and the precision is quite good, I will say, if you compare it with the Uni-T. So for high speeds, I will say that this with 3 magnets works quite good. As I said, it's not so stable as the one from the simpler one, but it's working and it's updating faster, as you can see. So this is the max speed. It takes maybe 1-2 seconds more on this one,
and the precision on this one at high speeds is also quite good, I would say, but less stable. So the Uni-T is stable. This, it's okay, but not so stable with 3 magnets, and this is stable as well. So now what we are going to do, you can see it's updating faster. What we are going to do is to change to 2 magnets, okay, on this one. So now we are doing the same but with 2 magnets, okay. So as said, the late, it has 1 magnet. The advanced one, let's call it like this, it has 2 magnets. So before we were testing 3, now we test 2. So let's start with low speed. As you can see, this is faster, and now the precision is much better. So as you can see here, it's 30.4, 30.6, 30. It changed a bit as well, but as you can see, it also changed here. So I would say that was due to the VFD. So I said much better. If we stop, this stop earlier than this one, so it works faster. Mid speed, update ratio, this is much faster, and the precision is quite good as well. 635 here as well and here, but here we have 1 extra decimal. And as I said, it's always updating faster, as you can see, right? So it takes like 1 second, maybe less. And the speed or the precision with high speed as well with 2 magnets, it's 1290 something. Here 1287, so I would say it's quite stable as well, as you can see. 87, 87 and 87, but the update ratio is faster, as you can see. So my conclusion is that with 2 magnets it's better. I would say that with 3 it has not that many advantages going with 3. Maybe the centering of the 3 magnets is a bit more complicated, that's why we see this difference. And now we are going to see with 1 magnet. Now we only have 1 magnet, so we are going the same testing, but in this case, in the ring, we only have 1 magnet. I am using these things that you see here. They are 3D printed and they are coupled into the late axle, so it makes my work easier. And we are going to do the same, so this time only 1 magnet. So let me start again. Okay, it starts. As you can see, the update ratio on this one, having only 1 magnet, is higher than this one. So I will say that with 1 magnet, lower speeds, this is better and also giving you more precision than this one. I would say that it is not so critical because it's only a decimal point, but I would like to show you everything. And the Uni-T is showing 30.4, 30.2, 30. Let's go to mid speed. So as you can see, the update on this one is much faster. So I will do it again. You can see that it is updating in a much faster way with only 1 magnet. And as you can see, the precision is 667, 667 with 1 decimal that it is changing, and 666. So I will say that with 1 magnet, the good one is more precise. And let's go to higher speed, update faster, via here as well. So we have 1087, 1087, 1087. So I will say at high speed they are quite similar, but in general this with 1 magnet has higher, or it's faster regarding speed update, as you can see. And yeah, as you can see, and I will say that it is a bit more precise than this one. Okay, so now I would like to provide you some conclusions from testing everything. I will say that in general this tachometer is much better than this one. It has a higher update ratio, it has also more options. So as pros, I will say, as said, higher update ratio, more options. It can also work as a counter. And as said, we can select between 3 and 1 magnet. It depends of the speeds that we need to achieve. And as disadvantages, I will say that it might change a bit more if we use 3 magnets. It's more tricky because it's not so stable on this one. And maybe it depends of the, you know, when it depends when we buy this one, might be a bit more expensive. But I will say that it is a good comparison. Now you can decide if you want to go to the simpler one, the one that you can always find, or if you want to go to this one, that it is a bit more advanced and it has a bit more options. So I hope you enjoyed this video. I will left links to these products, to this standard one, the advanced one, and the Uni-T as well speedometer in the description, so you can go there in case you want to buy one of these. The inductive sensors, they come with the devices already, so you don't need anything else, just the power supply. And I hope you enjoyed this video. Please, if you like it, give it a like for sure, subscribe, and see you in the next one.